Okay, welcome everyone to our June 10th edition of the Rutgers Ornamental IPM webinar. My name is Bill Errickson. I'm the extension agent for Rutgers Cooperative Extension of Monmouth County, and I'm also joined here today by Steve Rettke, our IPM program associate, Tim Waller, our Cumberland County Ag Agent, and Erin Quinn, who is our IPM program support staff. And we're going to be talking today about some of the pest and disease issues that are coming up over the next couple of weeks in New Jersey. Just a disclaimer on the bottom, as usual, that a lot of the materials we're talking about are for licensed professionals, and they're applying to commercial settings in New Jersey by licensed applicators. So these recommendations might be different if you're in a different state or if you're from the landscape side, but also a lot of the information on the life cycles and the insects is going to be relevant. So just a disclaimer there. Also, if you have questions, we'll have time at the end. So save your questions, or you can type it in the chat as we go along. And this will be recorded and it'll be available to share. So we've got some important insects we're going to be talking about today. We've got our beneficial flower fly predator, oriental beetles, spotted lanternfly, warm season mites, soft scales, box tree moth, bacterial shot hole, some viruses, and black spot of rose. So those are some of the things we're going to be talking about today. And then also, if you look on the bottom, the box on the bottom is going to give you the current growing degree days for southern, central, and northern New Jersey right now. And so in southern New Jersey, we're at about 870, 780 in central, and 670 up in northern New Jersey. And that is just a range. Microclimates, of course, are going to be different. But as we go through the talk, you'll see the different growing degree days listed for the insects we're talking about. And you can look at where those are corresponding depending on where you are in the state. Okay, so just some updates from some of the things that we've been talking about the last couple of weeks. Tim put together a plant and pest advisory post that went out last week, giving some updates, and within those updates are on the red-headed flea beetle. We're getting to a stage of overlapping generations where the first generation of adults are feeding, and then the second egg hatch generation is about to start. And so the models can be a little bit less accurate and tricky once we have overlapping generations. So just make sure that if you have a management plan that you're sticking to it, keep monitoring for that pest, and check out the plant and pest advisory for the latest update on that. Okay, a very exciting update is we just launched our website for this program. So this is brand new. It's the Rutgers Ornamental IPM program website. And Erin did a tremendous amount of work on this. She did a great job with this. That QR code will take you there. This is the link to it. And when this PDF of the slideshow comes out, this will be a live link that you can click, sites.rutgers.edu/nursery-IPM. And we're building this website throughout the season. So we're continuously adding to it each week. But right now, what you'll find on the website is that we're building pest profiles for all the topics that we're covering for the webinar. So all the 10 or 12 different topics that we cover today, we're then adapting them to their own web page in the webinar. So if you remember from a few weeks back when we talked about spruce spider mites, now there's a page on spruce spider mites on the website, and southern red mites and ambrosia beetle. And so as we go through the program, we're building and adding on to this website. So by the end of the year, it will be fairly comprehensive. We're also adding all of the webinar videos, all the PDFs, calendar dates, all these resources will live on the website. So you can go there, you can check all of that out, and it's all accessible. We also have contact form if you need to send us any questions or anything like that. It's all living on the website. And we appreciate all the feedback that everyone has been giving us about pests that are important and things you want to see. And we encourage you to really keep that coming, because that has helped us to get this far and to develop it in this way. And if you think about things that it might be helpful to have one way or the other, please share that feedback with us, and we'll try to incorporate that to make it even better. Okay, so let's talk about some insects that we're going to look at this week. This is our first beneficial flower fly, or the syrphid fly, it's also called, or a hover fly. And these look like little bees, but the adults are actually, they're actually flies. So that's the adult that we're looking at, and they do look like a little bee. They don't sting because they're a fly, and the adults are not the predators. So they're kind of a generalist pollinator, just beneficial in that regard. But it's actually the larva, or that it's a maggot because they're flies, and those are the ones that are predators. And so the adults are going to lay their eggs actually in the vicinity of colonies of the prey source. So aphids are their main food source. They'll also eat several other types of pests, but the adults are going to lay their eggs in that vicinity. Then the larvae hatch out, and they're going to start to feed on the aphids. So the adults, generalist pollinators, and then it's going to be the juveniles, the larvae, that are the predators of aphids. And you can see them there. We've got some different pictures. The adult in the middle, again, looks like a bee, but it's actually a fly. And then the larvae zoomed in are maggots, fly larvae, and they have a hooked mouth part, and they will consume aphids and the other pests. And so at their peak, supposedly they can eat 1 aphid per minute. So that's a pretty voracious predator. So it can be really helpful for keeping those populations down if aphids are a problem for you. So things that we can do, again, for keeping our beneficials throughout the nursery and throughout the landscape, is having diverse blooms, native species. Yellow flowers, white flowers will attract these in particular, and ample nectar and pollen for them. So we want to try to support them, and then try to be considerate about the when and how and what materials we're spraying when we are. So insecticides can kill flower fly adults or larvae, or disrupt their behaviors, preventing them from thriving. And a lot of the times the flies might be exposed through contaminated nectar or pollen or residues on the leaves or flowers. So just make sure you're always following the label instructions. So for systemics, a lot of them will have limitations about application when flowers are in bloom. And it's because those materials can get into the flower, get into the nectar and the pollen, and then we're killing off our non-target organisms like the syrphid fly, whereas we're trying to target leaf-feeding pest insects, but it also gets into the pollen and the nectar. So just want to be aware of those things and be conscious with our applications. Okay, so the first pest we're going to talk about today is the oriental beetle. And so this is different than the Japanese beetle. This is a different species, and they come out a little bit earlier, usually like 10 days, 14 days or so earlier than Japanese beetles. And the adults of the oriental beetle are just about becoming active now. Mid-June or so through early July is when the adults are going to be active. And they'll do a little bit of feeding damage, the adults, but we're mostly concerned about the larvae, the white grubs that are going to feed on the roots. And so what's happening now is that the adults are coming out, and they're going to lay their eggs at the base of the soil, the base of the plants near the soil, and then the eggs are going to hatch, and the larvae are going to feed on the roots. And that's where we're going to see the real damage. And they can feed on a lot of different host plants, daisies, roses, hollyhocks, nursery stock, perennial grasses, turf. So they're pretty generalist in what they can feed on. And this is some of the damage. So, you see the adults again on the bottom, see the white grub larvae, those are the juveniles. They're going to be in the soil feeding on the roots. And if we look at those rhododendrons in the top right, we're seeing the symptoms, and we might not know what's going on there. We might even suspect Phytophthora happening, but whenever you see something like that, you want to pull the plant out of the pot, inspect the root system, and you can see on the picture on the left there that root system is totally gone. And then it's a matter of determining, was this root system destroyed because insects were feeding on it, or because a pathogen was degrading it? So there are ways, we talked about previously, how to diagnose for Phytophthora. looking at the roots, are those cells sloughing off the exterior of the roots? Good indication. So we can or you can dig around in the pot, see if you can find some of the grubs. It's going to be an indication that they're feeding in there. But that's the real problem that this insect is going to cause. There are some natural controls. So Beauveria bassiana and some other beneficial fungi and nematodes can parasitize them. I'm going to talk about in the next slide mating disruption, and that's a really effective way to help control this insect. Keeping plants healthy, trying to hand pick insects if you have small populations, covering plants, those can help also. If we're using contact materials, we're probably going to be, or insect growth regulators are probably going to be targeting the adults, and then systemics are generally used to target the grubs, the larval stage. But one of the things that's really encouraging is that there's this mating disruption lures and research has shown that this can be really effective and cost comparable to chemical treatments. And so what we're doing here, these are sex pheromones. So that it's a synthetic pheromone that was developed to mimic the chemicals that the females emit to attract males. And what they're doing is we're putting these out at about 20 to 40 lures per acre, and it fills the air with the sex pheromone and it confuses the male. And so they're going around and they're with all these different chemical signals, and they're unable to find the females. And remember, we want to really disrupt their life cycle so that they're not laying eggs, and we're trying to reduce the population of the grubs. And so if the male and the female don't mate because the male can't find the female, then she can't lay eggs, and we won't have the larva. So this can be a really effective way to manage this insect. Very minimal, if any, impacts on non-target organisms, non-chemical based applications. So really effective, good way to go. So you probably have all heard about the spotted lanternfly. So this has been a major issue in the Northeast, the Mid-Atlantic, and New Jersey, for the last few years. And their adults are starting to become active. We're seeing nymphs now. And the big problem from a nursery and landscape perspective is the sooty mold that they create, which can make our saleable plants unmarketable. They do have a piercing and sucking mouth part, and that's going to weaken the plants over time, reduces plant vigor. It might cause the leaves to wilt or curl. But really, what we see from a sales perspective is the sooty mold that's created from their feeding and their excreting the honeydew, and the sooty mold grows on their honeydew, and then the plants are covered in this black material, and they lose their aesthetic appeal. So that's a big problem. They can feed on many different species of host plants, but the tree of heaven is their preferred host. And so they're really a cool looking insect. We see the adults, the female on the left, on the top left there, the one on the left, the larger one is the female, and then the male is a little bit smaller on the right. And then on the bottom left, we see the egg masses. And I kind of think they look like spackle spread on the tree. And the fresher, newer egg mass is more pure white. And then the older one kind of weathers to a grayish color. And those can be tricky to find, but you can scrape those off to reduce their populations. Or you may have the uncovered egg mass, as we see in the center on the bottom. Nymphs, first through third instars are going to be that black color, and then they start to develop the red color in the fourth instar nymph stage. And so we saw kind of like in central New Jersey and Monmouth County, maybe 2 years ago, we saw kind of a huge population of spotted lanternflies, and it's been declining over time. They're still around, but not at the same level. And I feel like that's consistent in other areas as well, as there's a population explosion, and then there's natural predators that start to control them. Our regular controls in our nursery practices will affect them as well. And so their populations are kind of in check to some extent, more so than they were a couple of years ago. So if there's quarantines in your area, you still have to pay attention to those. The permitting process, check your vehicles, your tools before you're planting them out, and especially before you're shipping. You don't want to have a load of plants rejected for spotted lanternfly, so make sure you're being diligent about that. Contact materials, we'll take them out, pyrethroids, carbamates, and then the systemics with dinotepfuron being generally the regarded as most effective. Something really interesting too that some innovative nursery growers throughout New Jersey have been doing is actually creating tree of heaven trap trees and treating them with dinotepfuron. And so this, works on the idea that this is their preferred food source. They're most attracted to tree of heaven, but then if you treat it with dinotepfuron, which is systemic, they're going to feed on the tree and then they're going to die. And so it lures them away from the other plants, and we don't have to treat the whole nursery. We're just concentrating our chemical treatments in a very small area. Other pollinators are not going to be feeding on this tree of heaven trap tree, and it can take care of spotted lanternfly populations. So I have not seen, research on this per se, but again, there are several innovative nurseries that are doing this and they're having good success with it. So might be something to look into. All right, Steve, I'm going to turn it over to you.
Okay. Hello and good afternoon, everyone. And good to see many of you back again for another exciting lunch hour of these magnificent marvels of miniature malevolence. I'm going to talk about mites as well as scales, specifically the two-spotted spider mite, which I'll talk about first, and then I'll switch and transition over to some of our soft scale species, just a handful that I will talk about. And so the one that's becoming active now is because of the summer is arriving, and that's the two-spotted spider mite. It's the classic warm season mite that likes hot, dry conditions. There are other species of spider mites that like the same type of conditions, but I think the most common is the two-spotted spider mite. And so it indicates there the emerging overwintering females have already been coming out over a good while now, but they don't really peak until you get into the month of July. And so you see the growing degree days, that period from 1300 to 2000 is when they really reach their crescendo as far as their maximum populations. And that will be often in July and maybe the first week or two of August. And so just looking at the growing degree days, as Bill had already indicated, you see where we are on June 10th and where that corresponds with those numbers. All right, this is just a graph, a simple, more of a theory about as far as these two-spotted spider mites and their seasonal populations and how they change as we go through the calendar. You notice in May, starting, they really haven't done much in May. They're just beginning to emerge from their overwintering sites. The orange-colored females, which I have photographs of, they are coming out now, and they have been coming out for maybe a good week or two or so. And then they will be certainly observe them. I've seen them in nurseries already, and they increase exponentially, and they begin to feed a little bit, the overwintering females, and they start laying eggs, and those eggs hatch. And over a period of several months, as shown there, you can have 10 to 15 generations in an entire year. And so that can create a great deal of numbers of high level and a great deal of damage as well. And it's not until you get toward the end of September when you really see them downsizing as the cooler nights begin to develop, and they don't like the cooler temperatures, and you start having the females turn an orange color. And by the time you get into October, they pretty much have finished their life cycle for that year. Okay, and he's showing you the number of plants. This two-spotted spider mite species is a true cosmopolitan mite. Even though they don't really feed much on broadleaf evergreens so much, or even conifers as well, they do feed on many deciduous plants, including things like herbaceous plants. And far as greenhouse, if you have greenhouse plants that you grow, without question, the number one mite problem is the two-spotted spider mite. They're about 1/50th of an inch in size, so they're quite tiny. They have two dark spots on each side of their body, and I'll talk about that a little bit more later. And we already know that they come in the hot, dry summer, and then the females overwinter beneath the plants. When it gets cooler in late September, early October, they'll drop off the plant and they're an orange coloration. And you can see that happening. And they do produce a lot of extensive webbing. Of all the spider mite pests that we have, the two-spotted spider mite produces the most amount of webbing. Okay. And showing you some photographs. There it is right there. That's extensive webbing on some chrysanthemum plants, which were growing in the summer period, summer mums. And then moving down, I kind of go counterclockwise. You can see the burning bush, which is really the sentinel plant in the landscape and the nursery as well. You see so many of them feeding on the burning bush, uh, or the yes, the burning bush. And then also you notice the orange coloration, good close-up photograph, not my photograph, from California, showing you the orange colored females as they start preparing to drop off the plant. And the other one at the right at the bottom, you can just barely maybe make out what they would look like to the naked eye as I took this photograph with the camera. You can see a little bit of orange coloration. Maybe it's difficult to see. But then there's the stippling that they do, and that happens to be on a burning bush leaf. And they are piercing, sucking mouth parts, and so they do they move the green chlorophyll, and they cause that chlorotic appearance. And then you're showing there in the center upper portion, you've got the two spots. And let's kind of talk about that now. We have those two spots is shown on the left of a good photograph of an adult mite. However, why do they have these two spots? And this is kind of a curiosity. And there are a couple other spider mite species that will have those, but nothing quite compared to what they look like for the two-spotted spider mite, which is why they are given their name. But quite a curious photograph was taken on the right with magnification, and then also a blue stain dye with under lighting, under table lighting. And you can notice that the reason they have those two dots is because there's an accumulation of maybe some digested food, and then also fecal material. And I think it's primarily fecal material that they take a long time to get rid of. You can see in some of the images there, the photographic images, where they do have their entrails that are trying to get rid of the frass or the waste deposits. And so that's, I always joke about, wow, talk about just fantastic dinner table conversation. It's just really remarkable how that would be wonderful to talk about. So, all right, let's move on, please. And so as far as controls, they do indicate there that on the left, as far as cultural practices, mites, as you realize, they do like it dry. They will increase their populations when plants are drought stressed. And then also you don't want to fertilize plants during droughts either, of course, and that will also further increase their populations. They like that nitrogen, and because nitrogen is often a limiting factor in the natural environment. And then you can mulch to conserve the moisture. And as far as biorationals on the far right, you've got oils and soaps. We always like to go to those materials when they can work for you, as long as it's not too hot and dry and the humidity is not too high, especially with the oils. But there are a number of other things. We have the contact insecticides, the pyrethroids. Now, when you use pyrethroids, you have a tendency, as it indicates there under considerations, that you can maybe promote spider mite resurgence. Because when you use a material, a broad spectrum material like a pyrethroid, you're knocking out everything in the system, and it allows, after the material runs out, if its residual runs out, then the mites themselves, the pest mites, can build up faster than the predators can, and so then you got a problem with mite resurgence. And there are some systemics as well. And but notice, by the way, you're not going to see neonicotinoids, which people like to use for a lot of stuff. That does not work well against spider mites. Okay, and there's a few others I won't have time to talk about. All right, so let's get into the scales now. These are the soft scales. We've talked about armored scales previously over the last few sessions. And so these are ones that, that's just a sampling. I could have chose others. There's no real big deal why I chose these. However, if you notice the first two, the Indian wax scale and the calico scale, I have an asterisk by it. And it's been stated by many university researchers that these appear to be more difficult soft scales to control. Normally, I've always thought soft scales to be relatively easy to control compared to the armored scales. And I think generally that is a true statement. But now with the Indian wax and the calico, you do have a little more difficulties with controls. But you notice the growing degrees days and when the crawlers are coming out, which is all pretty much now. I think all of them have mostly come out, except maybe the up north, you've got not quite 700 yet. But even in central Jersey, we're not quite yet to the Cottony Camellia scale, but that will be arriving very soon. And so I always think of soft scales as emerging in June and July. And then always with soft scales, before I forget to say, I think it does say here on this slide, I'll say it now, it's at the very bottom, there's only one generation per year. Another quite an exception compared to many of our armored scales, which have two or sometimes more than two generations per year. Soft scales do produce honeydew, I think we all know that. Then you get that associated black sooty mold that makes the plants aesthetically look very bad. Hard to sell plants with black sooty mold all over them. Another difference between soft scales is the fact that they can move after they settle. And so they have the abilities, they don't lose their legs like and their eyes like other like the armored scales will. They make that cover over themselves. And so the soft scales, they maintain their legs, they'll feed in one location for a while, and maybe then they will move again later in the year, and they resettle there later on. With soft scales, there's no leaf stippling because they're feeding the vascular tissue. They're not feeding in the cells. And normally with soft scales, generally stating, you're going to have less horticultural plant damage. It's less of a plant health care threat than the armored scales are typically going to have. And only the nymphs overwinter, and then you have 300 to 2,000 eggs per female. Wow, what a difference between soft scales and armored scales, because armored scales usually have fewer than 100 eggs per female, sometimes as few as a dozen. This indicates, and I've stated this before when I was talking about armored scales, soft scales have some very vulnerable periods in their life cycle that the vast majority of them just never make it to adulthood. And so that's why the female has to lay so many eggs to have the ability to have a new generation. All right, so just remember again, soft scales are honeydew producers because they feed in the phloem just like aphids. And this is one on the left showing bark cross section versus leaf cross section. And of course, scales can feed in both the bark and the leaf, depending upon the species. And some species can feed in both at different times, typically, as they move from one stage to the next. And so just remember that the honeydew produced is from phloem feeders. All right, some good photographs here. The one on the left from Tim Waller indicating a real good shot of a calico scale. And that one is also being tended by ants, a little bit less visible, but on the right, you've got, that's actually not calico scale, but that appears to be tulip tree scale, I believe. And you can see the ants are very prevalent. And there's some white areas. I don't have my cursor with me. I don't have control of that, but you can see some white areas where those are actually beneficial lady beetles that have white wax. And what they're doing, they are mimicking the appearance of mealybugs so that the ants will leave them alone, because these ants will fight off the predators. And if they think that it's a predator, they'll fight it off. Otherwise, that they get fooled and believe it's a mealybug. They think it has a honeydew source, and so they won't necessarily fight it off. And you can see that one right in the center, that lady beetle is trying to get underneath the cover of that particular soft scale. All right, just a close-up of a Fletcher scale, and just remember that most soft scale species have egg and hatch crawlers in June and July. I've already mentioned that. And look at the number of eggs in crawlers. You see their little eyes there. Not great photograph, a little bit high resolution for the camera that I had, but this indicates hundreds and hundreds, and sometimes well over 1,000 eggs per soft scale female as they hatch out. All right, so now let's actually get into a few species, and see if I can fly through it. And Indian wax scale. This is a tough one to control. They do feed on both evergreens as well as deciduous plants. I see them in the nursery probably most commonly. I don't even have it listed there, but one of them is inkberry, also Japanese holly, and blue hollies, Chinese hollies. I've seen them on boxwood and euonymus a little bit less commonly, and they will feed on a few deciduous plants as well. But they do have this, it's even though it's part of their exoskeleton, so you cannot remove it, this gumball-like waxy secretions, that is actually part of the insect. And so it cannot be removed like an armored scale cover can. And so there are no males, and so it's parthenogenetic and all females, and therefore also they feed on both twigs and branches and not foliage. And so you won't find these feeding on leaves, just on the branches. And they overwinter as bark, rather as adults on bark. One thing that needs to be remembered, and I indicate there against with overwintering as on bark as adults, it states that dormant oils are less effective. And the reason why is, let's go to the next slide, I can show you. And it's up in the upper left. That scale was turned over, that Indian wax scale was turned over. And you can see the actual body of the scale, that purple reddish coloration. And look at the thickness of the waxy exoskeleton that it produces and secretes around itself. And so that's how they overwinter in that stage. And so dormant oils are not going to be able to penetrate that waxy cover. So that's why they're so difficult to control with dormant oils. I wouldn't even waste my time trying it. And there's just a cluster of adults there to the right of it. And then when they first, well, let's go to the bottom left, they have some hatching out, and the many hundreds and hundreds of eggs can occur. They're about the size of a pollen grain, each of these scale crawlers. You can just barely make them out, that red circle. And then look at all the eggs at the bottom center. It's probably a combination of crawlers and eggs. And then the upper center, you see the cameo or first instar stage. And when they emerge in their crawlers, and they've got, again, I've stated this numerous times, they've got maybe 48 hours to find some place to settle and start feeding, or they run out of energy. And then initially they take a while to form this secretion of waxy that's part of their exoskeleton. And so it's only partially covered the scales. And so this is also a vulnerable time to spray for them with, you can get control. And so you don't spray against the adults during the dormant period, but only after the young crawlers have settled. And maybe it takes a few weeks before they get that real thick waxy material. So you have some time to control them with oils if you desire. All right, so this indicates some of the controls. I just want to emphasize horticultural oils, not during the dormant period. You have some insect growth regulators that can work. You have the various contact materials, pyrethroids and carbamates. They can work well against crawlers as well. In fact, almost anything usually works well against crawlers, even as I indicate there on the left on the bottom, it says syringing. And so you can knock them off with water, but you'd have to do that multiple times because it does take a while for all their eggs to hatch. And then you got some of the systemic insecticides there in the center, and metocloprid, dinotefuran, the neonicotinoids, they all work well. And then the translaminar material as cephate works against, I think, foliar feeders if they're going to be on the leaves. So, all right, I think I've said enough there. Let's move on to the next scale. And that's the calico scale, another one that's a really apparently difficult control. And this is University of Studies have shown, for some reason, many of our materials that work well against almost all the other species of scales, soft scales, the calico scale seems to be an anomaly where we just can't seem to find something that really works well. And so they look at all they have, they only feed, by the way, on deciduous plants. You will not find calico scale on evergreen, either needled or broadleaf. And so there's a good number of plants they do feed on. I think I've seen them a lot on honey locusts, certainly on, I've seen them on sweet gum and maple also. But it says that they don't emerge until mid-June, which is now. Then they do continue to emerge well into most of July, And by the time you get to August, they're pretty much finished with their crawler period. And then what they will do is another one that's a little bit different because they're able to, the nymphs, the crawlers, they move to the leaves when they first hatch out. They're not, they may be going to be, in fact, they will be hatching out from the mother who's on the stem. By the time she becomes an adult, they're going to be on stems. But when the young hatch out, crawlers, they have to go to the leaves and they feed along the veins. And that's where they'll be for the summer. And that's a difficult control, especially if you have larger shade trees. That kind of control is difficult to get with contacts. And so, and then before the leaves defoliate, later into the fall, they have to move again because they don't want to drop off with the leaves. So they move again. They have their legs and they can move back to the stems. And that's where they'll overwinter as second instar nymphs. And that's another time when you can control them, by the way. And it's also when they're very vulnerable as well, not only on the leaves, but on the stems against predators. And that's why they really have so many vulnerable periods in their life cycles that makes them vulnerable to predators. And so, all right, I got to keep going because I'm going to run short of time. And is showing you here the first instar nymphs. These are the calico scale again. They're feeding along the leaf veins, and that's where they'll be for the summer. And then before the leaves drop off, they have to move back to the stems, and that's them second instar nymphs overwintering on the stems. They size up quite a bit, and they also darken in color. Many of them are like a dark brown or almost a black color. I assume the reason for that would be so they can absorb light better and to keep them warm during the winter. And so, but they're so vulnerable at that stage, and that's why they really have to lay so many eggs because so few of them will survive to become adults. All right, so there's another photograph, the upper right, showing you the dark colored second instar nymphs. You got the eggs hatching there at the bottom left, hundreds of eggs coming out of that female calico scale. And then also you can look at all the parasitoid exit holes. Our parasitoids can really do a good job for us. I know I've emphasized that with armored scales, but also with soft scales. And unlike armored scales, where you normally have just one scale and one exit hole because, these armored scales are smaller, with these bigger soft scales, look at the number of holes that are in some of those scales. I think you could have maybe a good half dozen on a few of them. And so they are large enough where they can support quite a few of the wasps that will feed on the much bigger scale. And there's a photograph from our friend from Ohio State, Joe Boggs, some of the best photographs in the industry, showing the first instar nymphs along the leaf veins in the summer. And so you can see how they're all lined up along that central vein of the leaf. All right, so controls is pretty much similar already to what we talk about. Just remember, this is also a difficult one to control. And so some of the ones that we've been attempting to use, the oils and the soaps and even the systemics are not seeming to work so well. Even the dinotefron has been showing struggles at times against the calico scales. And so what has been stated by some of the researchers, what gives the best efficacy, and we don't like to use a whole lot of this, is bifenthrin, which is a pyrethroid. And so that's been shown to give the best results sometimes against these armored scales. And so if you have to resort to that, that's something you can at least rely on. And so I'll have to keep moving on. All right, so cottony camellia scale, just a few minutes left. They are going to be feeding both on broadleaf evergreens and deciduous trees. I've seen them mostly on hollies, blue hollies in particular, and one thing I could even rename this is cottony taxa scale, and it's often called that. So you can see the hue and the holly are probably by far the most common ones I see this particular scale feeding on. It's got a very large egg oversac that the female produces, where you can literally have, well, I don't know if it's 1,000, but 500, 600, 700 eggs in that quarter-inch long oversac that's surrounded with white wax. And when the eggs start hatching, which is going to be soon in central New Jersey, and perhaps they've already begun to emerge in South Jersey, maybe a little while yet before you get them up north. But once all the eggs are laid, and they're going to be almost exclusively found on the leaves. Rarely do you find them feeding on stems unless they have extreme populations. And when the female finishes laying eggs, as I was trying to say, they die and they just often disconnect and drop off the plant. And all you have left are these white oversacs with hundreds and hundreds of eggs. Okay. And this is showing an extreme infestation on a holly there in the upper left, in the center as well. There's the actual oversac on the bottom left where the female's already dropped off. You can maybe start to pick up some crawlers that are starting to emerge. And then in the upper right, you've got, I kind of removed before I took this photograph, I removed the waxy, protective covering which kind of covered up the eggs, and you can see all the eggs, and there's crawlers starting to move out as well. And the bottom center, you just have them feeding on taxus needles. Okay. All right, so I'm really starting to move past my 20-minute max as far as controls. This one's not all that difficult to control compared to maybe the Indian wax or the calico. They're really not difficult. The oils can certainly work well. I know a lot of people don't use soaps, and I myself, and I was in the industry, I didn't have a lot of experience using soaps, but I do know people who have combined the two, oils and soaps. Well, they'll do that on occasions with a pretty low percentage of the soaps. So if by chance they get some of this black sooty mold that's growing on the foliage, and the soaps will help to dissolve that and make the plants look a little more presentable. Okay, all right, so let's see, my last one is the Fletcher scale. Let's see if I can just cruise through this very fast. And they are going to be feeding only on evergreens and on either needle as well as broadleaf. And they have kind of a brown coloration to them. They get a pretty good size when they're fully grown as adults. And this is just the one generation, which is, I think I've emphasized that enough. There's only one generation for all of our soft scales that we talk about. They do produce honeydew. And so you see them growing on that arborvitae there, pretty prominent. And the crawlers will be emerging. In fact, they've emerged everywhere now, and they'll continue to emerge as we go into July. Okay. All right, so there's a close-up of an actual Fletcher scale that was turned over, looking at all the hundreds of eggs that are there underneath. And there may be some active crawlers that will begin to emerge. I'm sure there's some active crawlers in that menagerie there of mass of crawlers and eggs. And I think that's pretty much what I wanted to say here. Let's kind of finish up. And as far as control, same thing. This is not a difficult one to control. All the same materials at work can do the job. And so let me put a stop to it there. And so Dr. Tim Waller is next.
All right, thank you very much, Steve. All right, everyone. So I wanted to talk a little bit about box tree moth. This has come up in prior iterations of these webinars. If you're following along on the Plant and Pest Advisor, I've put a lot of posts up about box tree moth, but just kind of wanted to give everyone a refresher. We're going into a new part of the season. We're in the part where we've sold a lot of our plants. There may be this opportunity where we're receiving calls back from people that purchased our plants. A lot of plants moving around. So in general, I think it's a good idea for us to talk about this. So the images you're looking at here are some of the symptoms that you're going to be seeing on boxwoods if box tree moth were present. To our knowledge, it's not present in New Jersey yet, and we hope to keep it that way for as long as possible. So this image here shows the caterpillar form. This is a Lepidoptera. This caterpillar will transform into this moth here with those characteristic crescent moon shapes on the side of their wings. That being said, we're very unlikely to come across the moths unless we are trapping for them with pheromone lures. And we're much more likely to run into the caterpillar, which is this green green and black striped caterpillar. So this is, I pulled this map off of APHIS yesterday. I wanted to make sure that I had the most up-to-date map. As you can see, box tree moth is around us, or there have been incidences of box tree moth. Whether those populations were completely eradicated is something else to consider. So this is an insect that has been working its way throughout Europe. It's pretty much colonized all the European countries. It can be a real problem on boxwoods. In Europe, there are endemic stands of boxwood, so it can really move through Europe rather quickly. What we have in the United States are highways of boxwoods, either in landscapes, and we also have our shipping industry moving boxwoods around. So as you can see, it's in a number of locations surrounding the Great Lakes regions. And there are populations that are moving localized to those areas. Something that's really important to note, though, is that if you see boxwoods that have a defoliating caterpillar in them, there's a very high probability that what you are actually looking at is box tree moth. What concerns me a little bit, and time will tell, as this pest becomes more established in the Northeast Great Lakes region of the United States, is what other of our nursery crops that it will actually feed on. There's no reports of it yet in the United States, but in Europe it also has been found feeding on many different crops. So there's a federal quarantine. There is a compliance agreement that you need to be cognizant of, and if you are bringing plants in, you need to make sure that you're getting a compliance agreement if plants are coming from these quarantine locations. And the other thing I'll just state here is we use enough pesticides generally that would mitigate this pest in the nursery, but upping preventative sprays just for this pest is not really a good idea, because we're going to be reducing a lot of our natural predation, and it really stands to disrupt our IPM programs across the board if we're just using preventative sprays. So like I said before, there is a federal compliance agreement. If you're getting this is just one of those things. Make sure you've got your paperwork. This is an important topic, and make sure you're getting paperwork if you're getting plants in from those regions. And this is a really useful compliance agreement explained, put on by the HRI, and it's worth looking into. All right, so why are we talking about it right now? Well, we are approaching the time frame where potentially you could see multiple generations simultaneously. We're approaching a time period where we can have overlap between the adults, the moths, and the caterpillars, or the larval form of these insects. So this is a Lepidoptera, meaning it goes through these different growth stages. And there are researchers working on developing better grow and degrade models that can help all of us scout and be ready if this pest becomes a problem for us locally. And one of those researchers is Alejandro Del Pozo from Virginia Tech. And he's working with folks in Ohio as well as folks in New York up at Cornell. And they've put together a lot of really good research. First, looking at the grow and degrades, where they're trying to get a better understanding of when the adults are going to be present versus when we're going to have the caterpillars or the early instars of these caterpillars being present. So this is giving us something that we can work on, and we can be better prepared if we're receiving plants. And if we get into a situation where we've got this local to New Jersey, we're going to be able to manage it much more effectively using these models. And the graph here is just showing us when we're kind of having the peak days. Granted, this is in New York, so it's going to be slightly different than in New Jersey versus Ohio. But it's giving us an idea of we're having the first adult population, we're going to have a lot of eggs, a lot of caterpillars, and that's going to lead to a later explosion of the adults, and then we're going to go throughout the season. So luckily for us, it's a Lepidoptera. Everything that works on other caterpillars is is on the table. We've got BTK that can absolutely take it down. If you go to the resource that I have shown there from Virginia Tech, they've got some images of what these caterpillars look like when they've ingested the BT. There are a lot of other compounds available as well, and that group at Virginia Tech also did some research looking at some either translaminar or systemic materials or things approaching the biorational realm. And what they found was that foliar applications of many of these materials can give us some pretty good control over this insect. Just like spotted lanternfly, it's a relatively easy insect to kill, but the ramifications of them existing in a nursery landscape in the state of New Jersey can be a big deal. And every other state that's on the call that currently does not have a quarantine in place for them. So just be mindful. This is something that should be on your radar, and you should be doing your homework about it. And if we get any news or you suspect that this is happening, please give me a call. And my contact information is listed somewhere in this. All right. So now we're going to change gears a little bit, and I'll put on my plant pathology hat. So bacterial shot hole. So this is one of the more confusing disease issues that we run into in the nursery. This can be in container production. This can be in field production, out into the landscapes. So I was going to talk about both fungal and bacterial shot hole originally, but we're going to focus on bacterial shot hole because it's going to help us with our diagnostics. Most of the time, this is caused by Xanthomonas if it's bacterial in origin. In some of the tree species of cherries, there can be instances where we're looking at Pseudomonas. And we've seen this purplish red with yellow halos, and then ultimately the plants end up looking like they were shot with a shotgun, which is where that name comes from. One of the differences between cherry laurels and our tree species is that in the trees, those leaves are going to drop off from the plant. Oftentimes they'll start to turn yellow, and then we'll have these big defoliation events. That can be really, really stressful for those plants. The two that in the cherry laurels, I see it a lot in skips. Autoleucin will also have that as well, and the slightly different symptomology in the tree species. So some of the fungi that could also cause a almost identical symptom are listed here. Cercospora, if Cercospora is present, we're going to see the presence of Pycnidia if we look really closely, and we'll see those little tiny dots. And these other pathogens are very much could be present, which leads me to when it comes to managing these, we have to know what we're up against. If we are applying antibiotic and it's really a fungus, or we're applying an only fungicidal compound against a bacterial issue, we're not going to have a good level of control. So I'm going to kind of approach the whole situation and then break it down a little bit. So reducing leaf wetness. This is important in all of the cases when we're talking about foliar pathogens. Spacing plants out. I know we all try to make sure we don't have plants touching. If we do have plants touching, or we've got a really, really dense canopy, this is a great opportunity, especially because it won't quit raining, for things like this to really manifest and become apparent this time of year. If you are pruning plant material to increase airflow, which is generally a good thing for plant pathology, just make sure you're doing it in dry conditions and you're sanitizing your pruning implements. There are some resistant varieties that have been reported as well. If you're dealing with a tree species that is dropping its leaves, make sure we're getting that dropped leaf litter out of there. So luckily, we've got some materials that kind of give us some level of control against both a bacterial shot hole and a fungal shot hole issue. Our coppers, our combo copper products like hydroxide and mancozeb, commonly known as junction. Mancozeb, even mancozeb alone can give us some level of control for both our bacterial and our fungal issues. Bacterial suppression, we've got our antibiotics, and we've also got Bacillus ameoliquifaciens strain D747. And this comes in a number of trade names or in combination with other strains of material as well. If we're definitively trying to manage just a fungal issue, azoxystrobin and our regular heavy hitters, chlorothalonil and T-methyl, can be really helpful to us. So just to reiterate, shot hole is a symptom. We need to use diagnostics to figure out what we are actually dealing with. Some growers, and I've read this from multiple universities, and it lines up with conversations I've had with a number of growers throughout New Jersey and different parts of the state, is they get a reduction in the shot hole appearance if they have those plants in the ground, and then they scale them up in a container the year before they go out for sale. Just be aware that even though copper is a great compound for combating this issue, if we're going in too high of rates, we can make symptoms that look very similar to this issue. And a lot of these materials listed do have very long REIs, and I know how problematic that is, but in some cases that may be worth juggling if this is a common issue that you're regularly dealing with. All right, so just a couple more things to talk about here. I'll try my best to keep us all on time. Is that I just wanted to bring up, and this is not so much a teaching opportunity, it's just a reminder period to make sure you're looking through some of your older stock or plants that you plan to sell next year or plants that you just received in, is taking a good look for viral symptom expression. There's many different viruses out there. And we've got all these different symptom types. Some are more common than others, but make sure you're keeping an eye out for them. And there's really nothing we can spray or directly do to manage them. But we need to know if we are actually dealing with a virus, particularly when we get into viruses that cause leaf cupping or distorted growth appearance. That could be caused by a bunch of different things, whether that's herbicide phytotoxicity or feeding damage during that bud development phase by a pest. So using our diagnostics to figure out if we have a virus, and maybe we can figure out exactly which virus it is, that arms us with information about how they're spreading. What is their vector? What can we do about this? Across the board, though, if you have viral symptomatic plants, those should be rogued from the production area. If you think you've got a viral plant and maybe that virus is vectored by an aphid, and we've got an aphid explosion, we now have a lot of plants that we very possibly could have viral symptoms in, or viral contamination in. Want to make sure that we're always pruning cleaning our pruning equipment, because a lot of viruses are vectored in the sap of plants, that sugary matrix. And then controlling whichever vector is associated with the viruses that we are trying to manage. Thrips and aphids, leafhoppers, those are some big ones, nematodes as well. It's just a list here. I pulled this out of another talk that I've given, but it's just kind of, and this is not exhaustive, but it's just to drive home the importance of when it comes to managing viruses, which we have no real recourse against, is to make sure that our IPM programs are targeting the insects that could cause these viruses to come about. One thing I was remiss in saying in the last slide there is that viral expression, by and large, is triggered during stress events. Now, you can have plants that have multiple viruses in them, but if they don't go through the right type of stress, you may never know that. So this is why you can have viral expression in places where you thought the plants were totally clean a year before. So it's just something to keep your eye on. All right, and then I'm just going to end here with black spot of rose. We're getting into the time frame where we could really start to see symptom development. This could have been happening for the last 3 weeks-ish, 4 weeks, or so. But just to reiterate for completeness of this course, we thought it was important to include this one as well. What's important about this particular disease is if we go through multiple iterations of our roses defoliating, that's a severe stress to that plant. That's going to make any of the other conditions much more exacerbated. And not to mention, we are not going to be selling those plants if they're covered in this fungal disease. Just some more images of it here as well. In the landscape, this can absolutely take plants out, but if we've got a good preventative cover spray program, this is something that we can get a handle on pretty quickly, because a lot of the materials that we're using to combat a lot of the other pathogens that we are worried about attacking our foliage are going to be handled with these sprays. If you grow a lot of roses, you know full well that there are a lot of sprays associated with producing a pristine rose that is free of any type of disease symptom. So that this list here is something that is really going to help us. The list of materials here are something that we're already using in a lot of cases as well. All right, so thank you very much. We're trying to keep everyone on time here. So next week, we're going to be talking about a number of these topics here. A couple of things that I personally wanted to add into this is being a plant pathologist background. I wanted to talk a little bit about our post-spring big hit. I want to talk about house sanitation and just some concepts too that can really help us avoid a lot of these issues if we can make sure we're starting clean in those houses, as well as a phytotoxicity diagnostics. That's one of the big questions I get on a regular basis is, are we dealing with phytotoxicity? Are we dealing with a virus? Or are we dealing with some unknown, whether that be an insect pest or a disease issue? And with that, I just want to say thank you very much. Thank you very much, everyone. And please go check out the website. And if there is ever a topic you want us to cover, ideas, things you could use more emphasis in, we'd all be very happy to receive that information. All right. Well, thank you very much, everyone. We're going to